Good morning. My name is Leah Sandler with the Michael Fields Agricultural Institute, and I'm here today to talk a little bit about male and female plants, as well as pollen drift in CBD hemp production. We know that CBD hemp comes from the genus Cannabis species sativa, and that it's an annual plant. If it has 0.3% THC content or above, it's considered marijuana and is used for medicinal or recreational purposes, but that if it has 0.3% THC content or below, it's considered industrial hemp. It is grown for a wide variety of uses, but the three dominant ones being seed, fiber, and CBD, which is what we're going to talk more about today. So where does CBD come from? CBDA, which is the precursor for CBD and is what the plant secretes during the extraction process. When CBDA is heated, it is turned to CBD. But CBDA is produced by the trichomes on female flowers, the surface of the female flower. And so you can see in this left-hand picture the female flower with lots of little white specks along the leaves, and those are the trichomes. On the right, we have the magnified version, and you can see that these little glandular hairs. So these little hairs with these kind of bulbous jelly-like tips, and that's what's making the majority of the chemicals that hemp is known for. So we're talking about CBD, but as well as terpenes, flavonoids. Most of these are produced from these glandular hairs called trichomes on the female plant. Important for this discussion, cannabis is also dioecious, and this means that male and female flowers are on separate plants. So there's male plants and there's female plants. And that additionally, it's wind pollinated. So male plants that contain male flowers produce the pollen, and that this pollen is distributed via the wind to the female flowers that then take the pollen, pollinate the flowers, and go towards seed production. So in CBD hemp production, we're trying not to pollinate the female plants, and I'll explain more about this later. But so this is important because, and then in terms of differentiating the plants and the flowers. So cannabis has what is called pre-flowers, and this means at their nodes, which are where these leaves or branches come off of the main stem, there'll be little flowers that will indicate whether it will be a male plant or a female plant. So on the left-hand side, we have what's the male pre-flower, and this is going to look like a little bulb that will become the pollen sac. And then on the right-hand side, we have the female flower, and you can see it'll have this kind of bulb, and then it'll have this pistule that's kind of starting to come out, which will be characteristic in the full plants as well. Excuse me, the full flowers. But by the 6th week or so, you should be able to start seeing these pre-flowers, and that can help determine which sex of the plant. And so one is able to remove the male plants, thus removing the pollen. Here we have some pictures. So on the left-hand side, we have the female pre-flower. And as I mentioned before, you can see this little pistule structure coming out of this bulb. And then on the right-hand side, we have the male pre-flower. And you have these little bulbs that are basically what the pollen sacs will look like as they grow. And so that kind of translates to the full flowers, which we see here. So on the left-hand side, again, we have the whole female flower with all of these white little stems being the pistules. And then on the right-hand side, we have the male flower, and you can see all of these pollen bulb sacs. And some of these are open. So on the top here, we can see the top right-hand picture, the sacs are starting to open, and those anthers are hanging down, and that's what will release the pollen. Cannabis is an interesting plant in that it's predominantly dioecious, but that there are also monoecious varieties or partially monoecious plants. And so what that means is that there are male and female flowering parts on one plant. And so here what you can see is kind of on the left in the back there, we have a female flower. You can see those pistule structures again, but that in the forefront on the right-hand top part of the picture, we can see these male flowers and these pollen sacs. And so if when we're producing for CBD hemp, we want to remove all of the monoecious plants as well, because again, they contain pollen. So why do we want to reduce the males and thus the pollen? The main reason is that pollination of female flowers reduces CBD content. And what I have here is a graph to show this. So on the left-hand side and on the y-axis we have total CBD content. And so the three different bars, blue, orange, and gray, are just talking about the different where the flowers are in relation to the stalk. And so that's not so much important. But what is important to notice is that on the left-hand side, the pollinated flowers have significantly less CBD than on the right-hand side, those have not been pollinated, basically showing that with pollination, CBD content of that female flower goes down, and thus when we're producing hemp for CBD, we want to make sure that pollination is not occurring and thus reducing our CBD content. Additionally, to the fact that pollination reduces CBD, CBD hemp or hemp, industrial hemp in general, creates a lot of pollen. It's very prolific. And so some experts say that within 10 miles of CBD hemp, you don't want any grain or fiber production, particularly grain production, because for grain hemp, you actually want pollination to occur so that that seed is produced. However, in Europe and Canada, they've reduced that kind of distance to 5 kilometers, which is just over 3 miles, required for the highest class of hemp seed. And so this is a graph to show you why and what that looks like. So up here, this graph basically shows research was done to see how pollen moves over time or over distance. And so what you can see, it's called a leptokurtic curve, which means that as we move away from the center of the field where that hemp is, at first it rapidly reduces. At early distance, we see a great reduction in pollen. So within that first couple of meters, we see a reduction of 50% of the pollen. However, that drop off starts to slow, and so that there's still pollen quite far out from that initial plant. And so what the researchers kind of determined was that pollen was reduced greatly at first, but that as we moved farther away, there was still pollen in the air. And in particular, that wind movement really impacted it. So basically, pollen was distributed downwind 6 times more than it was distributed upwind, which makes sense. But that isolation distance of 5 kilometers on the downwind side was equivalent to an isolation of less than 1 kilometer on the upwind side. And so if we're looking at wind movement patterns, that isolation area of 5 kilometers could actually be greatly reduced. And so we're looking so that you wouldn't need to be isolated 5 kilometers on all sides from hemp production that was for grain. And so that's an interesting thing to take of note. However, we still, in our own fields, want to manage males. Even maybe if we're not able to control growers around us, we can definitely control our own fields. And so there's non-feminized seed and there's feminized seed. So non-feminized seed is about a 50-50 mix of male and female plants, but feminized seed is trying to get 100% female plants. And so basically you don't have to worry about male plants being in that mixture. However, I would like to reiterate strongly here, that is not a guarantee. If you buy feminized seed, it is not a guarantee that there will be no plants in it. So, and the difference is that in terms of seed, is located mainly in seed cost. So feminized seed is significantly more expensive than non-feminized seed. However, the idea being that you need less of it, because if you're buying non-feminized seed, you have to immediately get rid of 50% of those plants. Whereas feminized seed, hopefully you're not having to remove any, or if you are, it's only a few. Regardless of whether you use feminized or non-feminized seed, you need to be scouting your fields, and once it gets to flowering, almost every day, and removing male plants so that there is no pollen among your field. Additionally, you should be scouting nearby ditches, fence lines for feral hemp, considered ditchweed, that could also be introducing pollen into your field. And then the idea being that the minute you see a male plant or a male flower, pre-flower, as we discussed earlier, you're removing those. Another way we can reduce pollen in our fields outside of managing plants in our own fields is to block pollen from neighboring fields. So there's a couple ways of doing that. The first is indoor growth. So either using high tunnels, hoop houses, greenhouses. So if that's plastic, if that's glass, but basically you're producing the plants inside, and so pollen is not being able to enter into your production. However, that's highly resource intensive if you have high tunnels, as well as space intensive. A lot of the production in Wisconsin is going to be happening in open fields. So if we're in open fields, what are other ways we can block pollen? So windbreaks or tree lines can be really useful. They are really good at blocking pollen as well as blocking wind, or looking at the topography of your land. Is there hills, are there valleys, and knowing how the wind moves through your land and planting and putting that hemp in areas with low wind movement. However, it's also, if you don't have windbreaks or tree lines and don't want to wait 10 to 15 years to plant hemp, as well as have flat land, you can also plant annual species to help block the pollen movement. So a lot of growers will plant corn around their hemp fields, and corn will grow significantly taller than the hemp and should be able to block a lot of that pollen flow, as well as I spoke earlier about downwind versus upwind, knowing how wind is generally moving across your land and making sure that if you're downwind of other hemp fields, that you're really protecting those sides. So what you can see here is hemp planted in an alcove of a tree line, and that tree line is going to really help block pollen movement and wind movement. So in conclusion, there are a couple things for CBD hemp production that are really important. The first is to manage males in your own field. And this is because, as we've talked throughout, male plants are what create the pollen, and pollination of female flowers really drastically reduces CBD content in those flowers. Managing the males in your own field, whether that's from non-feminized or feminized seeds, as well as then planting in either naturally occurring windbreaks or planting annuals around your field to help in reducing that pollen movement through your field, and being aware of how wind moves across your land. And then finally, I believe what you're here today to talk about after this presentation is kind of who's growing what kind of hemp where in different counties, and trying to work together to make sure that if grain hemp is being produced with CBD hemp, that it's with outside of that isolation area of 5 kilometers, or and depending on upwind or downwind, what that looks like. And so just trying to come together as a group of farmers to determine who is growing what where, and how to reduce that pollen drift with the wind. So I will leave it there, and just want to say thank you very much. And if you have any questions, feel free to contact me. I have my email address here. And if you do have questions and I don't know the answer, I will be happy to find them out for you. So thanks so much.